Hi everyone. So today we are just going to continue on homogeneous equation. Okay, differential homogeneous equations. So what we are going to analyze today is just here I will solve this and this exercise. Okay, these were the remaining exercises that were in that list of exercise for homogeneous function. And secondly, we are going to add a new concept here. This is not, suppose we have a function that that is not homogeneous but can be reduced to an homogeneous function. A function like this, okay? And usually this method for non-homogeneous function that can be reduced to homogeneous function, usually they have, okay, this x here to, it's presented in this way generally, or you can arrange in this way. They can give you also in this way, okay, in a linear way, so then you can arrange in this way. But this only, we apply this only when we have the same exponent or the same degree for the first and the second expression of f of x, y, and then also for this x of x, when we apply only when we have the same degree here in the polynomial above and in the polynomial in the numerator. Okay, when the numerator polynomial has the same degree as the numerator polynomial, so we can apply this method. Okay, so it means that we can reduce them. Okay, and it is usually applied when this is for degree 1 here, 1 and 1 and 1. Okay, okay. See, we are going just to solve this one. We are going to apply the concept of homogeneous equation, then separable variable method to solve this exercise. Okay, just remember, any exercise that can be solved, but any exercise, if you have a differential equation and this is form of homogeneous function, it means that this exercise can be solved by applying separable variable method or variable separable method, but after applying the homogeneous substitution. Okay, the homogeneous substitution, that is making y equal to vx. Okay, now let us see for these two first. So here we have this function. Okay, here we have this function. This equation. This is a differential equation. Okay, this is first order and first degree. What we have to do, just, okay, we have just to reduce, okay, in a form like this one, as we know. Okay, we have just to reduce in this form, dy upon dx equal to minus mxy and upon nxy. Okay, this is what we have to do, just trying to solve this one. Okay, let us check first if it is homogeneous. Just see, this is x, degree 1, degree 1. This is x squared, y squared, degree 1, degree 1. Degree 2, degree 2. It is degree 2. If you try to take it out, it will be with degree x squared, y squared. It is degree 2. So degree here, it is 2 times 1 by 2, because it is root 2, degree 2, so this will be 1 also. Means that this function is homogeneous. Okay, is homogeneous because the degree here, okay, with dx is the same. The degree for this right hand side is equal to the degree of the polynomial of this right hand side. This is actually, this is directly, we can say that this is a homogeneous function. Okay, now check what we have to do now. Now we have to transform in this way, okay, just to make it up in this way. So how do we have to do, or what do we have to do? Dx with dx, okay, and dy, you can stay there. This will be x dy equal to, just solve this one. This will be root of x squared plus y squared, okay, minus all this. This is dx, so go there, plus y, and here dx as common factor. Now what's the next step? Okay, dy, come here, dx, and x go down. This will be root of x squared plus y squared, okay, plus y all upon x. Is that okay? Now that it's okay, what's the next step? Apply, knowing that this is homogeneous function, we can apply the substitution for homogeneous function, vx, y equal to vx. What's the next now? We have just to apply differentiation. Yeah, this will be dv, okay, dx times x, then plus v. Okay, the next step is just substituting this expression in the main one. Okay, we are going to substitute this double star and star in equation 1. I will call this equation 1. Okay, star and double star in 1. So what do we have to do? That will be x dv dx plus v equal to, where I find y, I'll put vx. So this will be x squared plus v squared and x squared all upon x minus plus vx. Is that okay? Now if we take x common, this will be x root of 1 plus v squared plus v all upon x, and here x dv dx plus v. Is that okay? Now x and x will be cancelled out, so what we are going to have? We are going to have v here, x dv dx is equal to root of 1 v squared plus v. Are we together? This v and this v will be cancelled out, so x dv dx is equal to root 1 plus v squared. Okay, now v, you can just send this guy there and this guy. Just try to organize, okay? Organize dv with the function of v and dx with the function of x. This will be dv of 1 root 1 plus v squared is equal to dx upon x. Now integrate both sides. Okay, this is plus c1, you can say c1 or c. Okay, nice. So integration of this will be what? As you can see, this integration will be ln of v plus root of 1 plus v squared equal to ln of x plus c. Okay, this is the result for this one. Now you have just to substitute. Okay, where you find x, where you find now whatever you see, just substitute. This is ln, we know that y is equal to vx. Now here we can substitute v will be y upon x. Okay, v will be y upon x. So in this expression where you see v, put y upon x, so it will be v, it is y upon x plus root of 1 plus y upon x square. Okay, equal to ln c plus, we can say ln of c. It's fine, okay. You can do this, or it's upon you. So now here what you have to do, so yeah, this is the expression, this is the equation. So even if you feel like you can just say like this, it can stay like this, so it's fine. So here you can send this guy here, or you can send this guy here, it's up on you. But only know what I can say, yeah, from here, it is fine. Sorry, from here you got this expression, x squared plus y squared all upon x, okay, equal to ln x plus ln c. This is fine. Now, this is the same of ln of y plus root of x squared plus y squared. Okay, this is dividing. It means that this is minus ln x, okay, equal to ln x plus ln c. Ln c is okay. So this and this can be ln x c, okay, and this can go there also, or this can come here. It's up on you, it's okay. So if you come this one here, if this come here, this is the same. It's like, even if you don't know, okay, let us just make it simple. This one can come here, okay, this will be ln of y, okay, of y plus root y squared plus x squared minus this. If this come here, this will be minus 2 ln x and ln c, and these two can come here. This will be ln y plus root x squared y squared, okay, all upon x squared. Okay, this come here, then it is minus dividing, equal to ln c. Now ln, it's okay, y plus root of x squared plus y squared all upon x squared is equal to c. So this is the solution for this equation, so we can write in this way. Nice. Now let's go to solve another one quickly. Okay, we are going to solve this one quickly, this exercise here. This is also a homogeneous function. Just by seeing, you can notice that this is an homogeneous function. We are going to show you this. Plus y cubed plus 3x squared y and dy equal to 0. See, can we separate these expressions? Okay, can we do this expression in terms of y only or of x only? This is impossible actually. Okay, this is impossible. Okay, if I just separate x here, take x common, this will not be a function of y. And if I take y, there is no y common. So here we have to analyze, is this function, is this and this, are this, okay, is this equation homogeneous, made of an homogeneous function? Check. Root, here it is cube, okay, what is the degree of this monomial? Cube. 3. The degree of this monomial? 3. What is the degree of this monomial also? 3. And the degree of this? 3. So the degree of this polynomial is 3 and this is 3. It means that they have the same degree, they are homogeneous. Yeah. So if they are homogeneous, so what I have to do is just transform in an equation, or in an equation like this, dy dx, m of x, y, and n of x, y. Okay, where this one will be your m of x, y, m of x, y, and n of x, y. So just put this one, okay, put this one there, then just solve this exercise. This will be dy dx equal to minus, okay, this expression up, okay, x cubed plus 3xy squared all upon, okay, all upon y cubed plus 3x squared y. Now, what's the next step here? Just do the substitution. Y is equal to Vx. Okay, it implies that dy dx is equal to what? This will be x dv dx plus v. Nice. If it is true, okay, let us call this one. This is true. Okay, this is star. This is double star. Okay, and this is what we call equation number 1. Okay, substitute double star and star in 1. Okay, if you just substitute this double star and star in 1, you get this x dv dx plus v is equal to minus, then stand this one. Where you find y, you put vx. So this will be v cubed x cubed plus 3, okay, 3v square, 3x square, okay, 3x square, x square, then y is vx. Okay, above it will be x cubed plus 3x, then v square and x square. Now what we have to do, just cancel this x cubed. Okay, x cubed here, this will be 1 plus 3v square. It's nice. Then downside, it will be x cubed v cubed plus 3v. Okay, this will be the equation. So what you're going to have, x cubed and x cubed will be cancelled out. This here is dx dv dx plus v. Okay, just like this simply. So x dv and dx plus v is equal to minus, okay, 1 plus 3v square, and here v cubed plus 3v. Now it's okay. It's okay, it's fine. So what's the next step then? So the next step here now is to put dv with the function of v and x with the function of the fx and with the derivative of x. So send this guy there. It will be x dv upon dx equal to minus 1 plus 3v square all upon v cube plus 3v, okay, minus v times v cube plus 3v all upon v cube plus 3v. Okay, after finding this common denominator, this is dv dx equal to this one. You'll find this one. Okay, just solve for this exercise. This will be all minus here, then this will be v cube plus 3v, and here just add these expressions. This will be v to the power 4, then this one, this will be plus 3v square, and here plus 3v square also, okay, because I take minus is common, okay, 3v square, then plus 1. So this will be minus, okay, v to the power cube, v to the power 4 plus 6v square plus 1, okay, and here it is v cube plus 3v. Nice. It's okay. This is x dv and dx. Okay, so what is the next step then? Okay, the next step here is just to send this dx here and dx with the function of x and dy and dv with this function of v, just like this. Okay, can we do this? Yeah, surely we can do this. Okay, we can do this. Okay, so here, now that we got this point, what is the next step? We have to put together, okay? Put this together. This dv must be with the function of v, and this dx must be with the function of x. So send the dx there, then dv here. This will be dv, okay? Here, see, this one will come here, and this will go down. So it will be the same as I write something like this: v cube plus 3v, okay, all upon v to the power 4 plus 6v square plus 1 equal to dx upon x, just like this. Now apply integration both sides, okay, because we could separate integration both sides. Now see, if you see this expression down here, this is v to the power 4 plus 6v square plus 1. If you derive it, you will get 4v to the power 3 plus 12v. Nice? What do you mean by this? This will be 4 here, and here 4. This is cube plus tv. Okay? If you check this is the same expression that you have here up. What does it mean? It means that if I just add 4 and take 4, the expression downstairs will be the same expression here in the numerator, but derived. So you'll get this one minus 1 by 4. I take 4. This will be d v to the power 4 plus 6v square plus 1 all upon v to the power 4 plus 6v square plus 1 is equal to integration of dx upon x. So, okay, plus c. So just solve this one. This will be minus 1 by 4, and this integration will be ln of v to the power 4 plus 6v square plus 1 equal to ln of x. Okay, ln of x plus c. Nice. It's nice. So now that it is solved, just substitute. We know that v will be y upon x. Why? Because y is equal to vx. Okay? Yeah. Now that you find this is okay, see, vx, so it's fine. This means that there will be minus 1 by 4 ln of y upon x to the power 4 plus 6 y upon x to the power square plus 1. Okay? equal to ln of x plus c. Sorry. Okay, plus c. If you find the common denominator here, it's okay for you. Okay, minus 1 by 4 ln, here it will be y to the power 4 plus, finding the common denominator, this will be x squared, and here you will get also y squared. Finding the common denominator, because this is 4 in this way, this will be x to the power 4 all upon x to the power 4. Okay, equal to ln of x. Okay, ln of x, then plus c. Now see, if you just call this guy to be here, okay, this guy to be here, you will get something like this. Okay, ln, okay, this is negative, so this will be inverse 1 by 4 in the exponent, so this will be x to the power 4, and here this one will be here. Okay, this one, when this come here, this will be here. This transformation is upon you. Okay, so x squared plus 6x squared y squared plus x to the power 4. Okay, yeah. Sorry, this cannot be here yet. 1 by 4 minus ln of x. Okay, equal to c. Now it's okay. So these expressions here that you can see, okay, okay, these expressions here that you can see, yeah, this can be expressed in only one expression like this. This will be here you have this and this. What does it mean? This will be ln of x, okay, x to the power 4 and x to the power 4. See, x to the power 4 and x to the power 4. Nice. So x to the power 4 and x to the power 4 will be 1 only, and then you get this one, y to the power 4 plus 6x squared y squared plus x to the power 4. Okay, all 1 by 4. Okay, minus ln of x equal to c. What's the next step? Next step is just you have this. Okay, this will be ln. This ln, this x and this x will be cancelled out. This will be only 1 upon y to the power 4 plus 6 square y square plus x to the power 4. Okay, all by 1 by 4 equal to c. C you can write like ln of c. This is the same. Okay, this is the same. So now here, okay, now that you have here this ln and this ln, this x and this x will be cancelled out because this will be the opposite in the other. Now what you have to do is just to equalize this expression to this expression. So our solution will be 1, okay, and here y squared, y to the power 4 plus 6x squared y squared plus x to the power 4. Okay, all raised to 1 by 4 equal to c. Okay, equal to c. Yeah, and you can also put here time 4 and here exponent 4. This will be only 1, and here it will be x power 4 plus what? 6x squared y squared plus y to the power 4 equal to c. Let me call this dash. Okay, equal to c then. It's okay? Yep. Hope you may enjoy. For here we are done. Now let us see when we have sometimes we have a function that is not homogeneous. Okay, it's not homogeneous, but we have to transform it in an homogeneous function. Okay, let me see a function like this. Usually this function that can be transformed to an homogeneous function, this function are having like a linear function. Okay, what I mean by linear function, they have a line like here you have 2x yx, so here the polynomial, okay, the degree of polynomial here is 1 and here it's also 1. Okay, if you see this function is written in this way, this one is with respect to dy and this is with respect to dy, so it doesn't mean that you have always in this way. Okay, this is the, how can I say, the simple form that I organize, because this exercise can be given also like this. Okay, dy, this one come here, 2x plus 3y minus 1, okay, and equal to, or minus dx times 2x minus 3y plus 2 equal to 0. They can give you like this, okay? I just made it in a short way so that if they gave you like this, you know that this expression cannot be cancelled or cannot be separable. And this expression do not have the same degree, or the degree of this equation or of this polynomial is the same, okay? They are the same, but it is not for all the monomial in this. So we cannot say that this function is homogeneous. So when a function like this, here the degree is 1, 1, 1, 1, okay, are not the same, because here it is 2 and here it is 2, but these 2 and these 2 are the same, okay? So we can just transform this in this way, okay? Let us just show it in a simple form. Suppose we have a function like this, dy dx is equal to ax, okay, let me call this a1, okay, plus b1 y plus c equal to a2x plus b2 y plus d. Suppose I have a function like this, okay, if a by b, it's like, do you know what does it mean? The rate of change m, if a1, okay, by b1 is equal, we know what is the rate of change, no? We know. So if the rate of change a1 upon b1 is equal rate of change of the first equation, okay, let me call this one, and the rate of change of the second one a2 by b2, okay, we can say this one m and m2. So if this a1 by b1 and a2 by b2 are equal, okay, like m1 is equal by m2 is equal to m2, okay, it means, what does it mean? It means that a1 is equal, a1 by b1 will be equal to a2 by b2. When this happen, okay, when this happen, so what does it mean? What does it mean when this guy is equal to this one? It means that I have to apply this, how can I say? I have to apply this substitution to make it homogeneous function. I have to apply this substitution. When they are equal, I have to do this one, okay? I have to do this one. Y is equal to, okay, a1, maybe a1 x plus b1 y, okay? I have to do this substitution there. Then apply the differentiation and go on and on and on, okay? But if, okay, just be aware, okay, when this one is equal to this one, so I have to apply this substitution, okay? I have to do substitution. Substitution is this. Apply this substitution only when the declive, the rate of change are the same, okay? Yeah, in case of this equation. But when the rate of change are different, so I have to apply, okay? Suppose if a2 by b2 is different of a1 and b1, so I have to apply y equal to, I have to apply a substitution like this. Y will be equal to y, okay, it's like big Y plus H, and X, okay, small x will be changed by a capital X plus K. You can do this one, H, capital X plus H, and capital Y plus K. Okay? Yeah. This is what we are going to do. Okay? Okay. Just understand, when the rate of change, okay, suppose we have this one, when the rate of change of this okay, of the above expression, the rate of change of this and this are equal. So what we do, we will apply the substitution. Okay, then we apply differentiation. But when the rate of change are equal, okay, we apply the when the rate of change are different, we apply the substitution over here. Okay, how to solve this one? That's the problem. Let's go. Yes, suppose we have this expression. Okay, this is a size. I will solve just for this one. How to solve this one? That's the problem, the point C. Now here you have just to see. If I divide, okay, if I divide 2, okay, 2 by minus 3, okay, this is the declive. It's like this is the rate of change. Just find M1 is equal to what? This can be A1 by A2. This is A by this one. Just find this one. Yeah, this one, this, okay? Just find the ratio between this and this. This will be 2 upon minus 3. It's like minus 3, 2 upon minus 3. Okay? This will be this. But for the second here, it will be 2 upon 3. It's like 2 upon 3. So what does it mean? It means that they are different, okay? M1 is different of M2. So in this case, when they are different, we have to apply this one. So here we have to substitute. Substitute what? Substitute X must be equal to capital X plus, okay, plus H. And Y, well, it's like it's upon you. You can call this Y, A, B, C, D, it's upon you. And here it will be capital Y plus K. Is it nice? Now just solve for this one. Just go there and substitute. If I substitute this, what will I get? This will be D, okay, dy. This will be like greater I and plus K, and here dx greater X plus H. Here it will be the same, 2, okay, H plus H minus 3 Y, it's like capital Y plus K plus 2 upon, this is 2, and this will be capital X plus H plus 3 capital Y plus K, and here minus 1. Now that you found this one, you know that this differentiation, this will be only D capital Y and D capital X. Now for here, just try to put together all the members that have capital, all the terms that having capital Y and capital X together. This will be 2 capital X minus 3 capital Y, okay? And everything that do not have capital, go there, go aside. This will be plus, okay, 2H minus 3K plus 2 equal to, upon, same here, this one, just put aside, and here I'll get plus 3 capital Y, and here plus 2H, and plus 3K. Is that okay? Yeah, minus 1. Okay? Okay. The next step here is, okay, now that you have this, what you have to do, the next step here is just to check and see. You have to do this expression equal to 0 and this expression equal to 0. So this will remain only this one. Okay? So this will be dy, okay, upon dx. This expression must be equal to 0 and this expression must be equal also to 0, this one. So if this is 0 and this is 0, what we are going to see? This equalize to 0 and this equalize to 0. What we are going to see? We are going to see 2x minus 3y upon 2x plus 3y. Okay? And here, what we are going to have? 2h minus 3k plus 2 is 0, and 2h plus 3k minus 1 must be 0. Okay? Now if you check this expression here, this is a homogeneous function. Okay? Now if it is an homogeneous function, you can do this one. Capital Y will be equal to V capital X. Then apply differentiation. What you're going to have here, this will be what? dy, and here the greater X will be equal to X dV d greater X plus V. Okay, so this is we call 1 star, okay, and this we call double star. And from here, all the concept will be repeated and everything will be the same. Okay, yeah, we have just to do and come here, substitute. This will be greater d dv dx plus v equal to, here it will be 2 greater x or capital X minus 3 v capital X, and here also true, and this plus 3, it will be v greater x. So you can here cancel this x can be cancelled. This will be 2 minus 3 v upon 2 plus 3 v. Okay, here it will be x dv dx plus v. Okay, just like this. Then from here you can send this v there. Okay, this v can be out there. This will be x d dv dx equal to, find the common denominator. What you are going to see, 2 plus 3v. If you find the common denominator here, this will be 2 minus 3v, and here 3v minus, this will be 2v, and also minus 3v square. Okay, 3v square. Then just try to solve this point and reduce this equation. This is x, this will be x dv dx, okay, equal to 2 minus 3 v, minus, here you see minus 3 minus 2 minus 5, minus 5v, okay, minus 3v square, all upon 2 plus 3v. Okay, now put together all the terms of v with dv and so on and on. This will be 2v, this will be 2 plus 3v all upon, okay, this term here. Okay, this term can be, you can just do the opposite. It's like 3v, as long as you take minus here, take minus 3v square, and here you have plus 5v, and here minus 2, equal to dx upon x. Yeah, just like this. Now what is the next step to be done here? Yeah, the next step to be done here is just to solve this equation, and this equation is very easy to solve. This one, you can just apply integration here and apply integration here. Now see, you have to be careful here. See, if you just try to integrate this expression like this, yeah, you have some problems. So you have to make it easier to you. Okay, so now here what we have to do, we have just to transform this equation in a very simple way so that it can be simplified, and so on and on. We can just find this solution of this equation directly. Okay, and how to find, that's the point, how to solve this equation. Okay, how to solve this equation. So see, we did here a good job. Okay, now here what we are going to do, that's the point. See, you have here this expression, okay, and if you see, this integration can be found here up. So the point is, How is that possible? Okay, how is that possible to find this integration here up? So we have just to find first, try to reduce this one in a quadratic equation. Yeah, just if suppose you have integration of u and u square plus something like this, okay? So you can just reduce this integration in this kind of exercise, or u minus this. This can be solved in this way, okay? Now see, here I have 3v squared plus 5v minus 2. This expression can be also reduced in a quadratic equation, okay? How? Come here and divide it all by 3. This will be 3v, divide it all by 3. If you divide all the expression by 3, okay, you are dividing by 3 and you are putting 3, okay, just like this. What you are going to have, you are going to have something like this, okay, 3 out. This will be what? V square plus, okay, 5 by 3 v minus 2 by 3, okay. I have to make this one a quadratic expression, a quadratic one, a perfect quadratic. So what I have to do, this will be 3 and v square plus add 2 and take 2, 5 by 6 v. Okay, now I can make it a quadratic perfect because here I have v square, the double, okay, of the first term times the second term. So I have to add here 5 square upon 6 square minus this 5 square upon 6 square. It's to make it a complete quadrant, okay? So I have to take it out. Minus 5 square by 6 square minus 2 by 3. Just in this way. What you're going to have, 3, here you got v square, okay, plus 2, 5 upon 6v plus 25 upon 36. This is a perfect quadrant like v plus 5 upon 6 square minus, here just find the common denominator also, because it is 36, it is, here I have to multiply by 18 only, because if you multiply this and this will be 36, okay, just like this. Sorry, no, I'm mistaken. This is by 12, okay, by 12. Then you're going to have something like this. This is 25 upon 36 minus 24. Okay, so this is 3v plus 5. Okay, this 3 is for all. So 3v upon 6 square minus, find this one. Okay, this is minus also. Okay, minus and minus plus. So this will be minus 49 upon 36. Okay, so it means that I can put this expression over here. Okay, I can put this expression over here. Instead of writing this as it is, I will write in this form, in this way. Okay, so that when I derive this expression, if I derive this expression, okay, if you derive this expression, this will be 0, and this will be 2 times this expression over here. Nice? So, okay, let me just substitute this expression there. So I will get minus integration, and this part upstairs, this is like 2 plus 3v and so on and on. Okay, so now just find, if you find derivative of this one, just suppose if you take this 3 out, if you find derivative of this will be 0, this will be 2 repeated here, and this will be the same. Nice? If you find derivative for this one, now try to find this derivative up here. Okay, deriving this, I will get 2v and so on and on. I will get something like this, 2, okay, v plus 5 by 6 du. dv. Is that okay? dv. Now, this expression up must be in there. Is there any way to us to find this expression there? Okay, yeah, there is. Now pick up the second term. It's like 2 plus 3v, okay, is equal to this one. Now you can just come here and take 3, okay, divide by 3, multiply 3 and divide by 3. Okay, multiply 3 and divide by 3. This will be 2 by 3 and plus okay, plus v, just like this. Okay, now it is true. Yes, this is true. So now what's the next step? I have to make it as v, 2 times v upon this one. Okay, yeah, just like this. Yeah, and how to do this one? It's very simple. Just add 5 by 6 and take 5 by 6. Okay, just add 5 by 6 and take 5 by 6. Okay, just like this. Okay, add and take. What you have to do to this one to be 5 by 6, you have just to add here 3 out. You have just to add what? 2 by 3 plus 3 by 3. Okay, that is 1. Okay, then plus v minus 3 by 3, that is 1. Okay, you can put here plus 1 minus 1. So you have this one, this is 3, and here it will be 5 by 6. Okay, and here you get plus v, and take this minus 1 out, this will be minus 3. Okay, then in this way you have this expression like this and this. So this will be easier to read. So you have to write here. Where you find 2 plus 3v, you can just write this expression. It's the same. This will be v plus 5 by 6 minus 3. Okay? Like this one. Okay? Where you find 2 but this is the same. And what else? What else is remaining? So dv. And here you will get something like this. 3. Okay, v plus 5 by 6 square minus 49 upon 36. Okay, in this way, you can just directly solve this equation. So this equation means that you are going to have 3 and 3 will be cancelled out. Okay, you are going to have only, this is v, okay, v plus 5 by 6 du dv all upon v plus 5 by 6 square minus 49 upon 36. Okay, just separate the integrations. Then here I will get minus, okay, the same, this 3 and this 3 will be cancelled out. This will be dv all upon v plus 5 by 6 all square minus 49 upon 36. Okay, yeah, just in this way. Now see, if you derive this expression here, what you are going to have, this will be 0 and this will be 2. Okay, if you derive this expression here, you will have this one. It's okay. So what is missing there? It's missing 2 here. Put 2 and take 2. Now this expression here, this will be minus 1 by 2 ln of v plus 5 by 6 only. Okay, it's like plus 5 by 6 minus, 5 by 6, okay, 5 by 6 square minus 49 upon 36. Okay, if you see well this expression, if you just apply some if you want to change, you can change, it's up on you. Okay, this is the integration. Now for this one, this is directly a formula. Okay, this is directly a formula. Now how to solve this? I will write again here. Okay, I will write again here. So we entered it in equations like this one, 2 plus 3v upon 3v square plus 5v minus 2 dv. This is equal to, we said that this is equal to minus 1 by 2, and integration of d of what? V plus 5 by 6 square minus 49 upon 36. Okay, if you derive this expression, you will get the same. Then upon v plus 5 by 6, okay, square minus 49 upon 36. Then minus again, okay, sorry, this is, okay, so this is minus out, so this minus and minus will be plus. Okay, now we are together. Plus integration of dv, and here I have v plus 5 by 6 square minus 49 upon 36. Okay, upon 36. What do you have to do? So this integration down, this will be minus 1 by 2 ln of v plus 5 by 6 square minus 49 upon 36. Then plus, and this integration here, I don't know if you can remember this, okay? This integration here, this is when you have u, okay? Like u square minus 1, this integration like this. Whenever you have du upon u square minus a square, okay? This integration is equal to 1 by 2 a ln of u minus a upon u plus a. Don't know if you remember this integration, okay? Here you can also see it is like du, dv. dv is the same of this. If I derive this expression here, this will be equal to this. So, okay, this is the same as I wrote something like d of v plus 5 by 6 all upon v plus 5 by 6 square minus 49 36. This expression, just substitute. This will be equal to what? This will be equal to minus 1 by 2 ln of v plus 5 by 6 square minus 49 by 36 plus, and this expression here, integration, this integration will be 1 by 2. 1 by 2a. What is a? We know this, this is 7 square and this square, okay? This is, a is 7 square by this one. This one is the same as dv plus 5 by 6 upon v plus 5 by 6 square minus, see, here it is 7 square upon 6 square. So this is a, 7 by 6. So here it will be 7 by 6. Now, ln of u minus v plus u by v, okay? This will be u minus v. What is u? This is v plus 5 by 6, okay? Minus 7 by 6 all upon v plus 5 by 6 plus 7 by 6. Just like this. Okay, a long integration, it's okay. Yeah, it is getting long because I just applied this integration. I just found it by myself, okay? I just made this exercise by myself, okay? Yeah, so this will be v plus 5 by 6 square minus 49 upon 36, then plus this 7, 2 by 2, and 3 will go up. This will be 3 by 7 ln of this, just find this one, this will be v, okay, v minus 2 by 6, it's 1 by 3, okay, 1 by 3, because here it will be 2 by 6, 1 by 3, then down will be what? It will be v and this, this is 12, this will be v plus 2. Okay, this is the integration. So after finding this integration, just change, okay, just after finding this integration. But see, this integration is for this exercise, minus 3v plus 2 dv upon 3v square plus 5v minus 2. Okay, this is the result of this integration. Now, that was, the equation was minus 3v plus 2 dv all upon 3v square plus 5v minus 2 equal to dx upon x. Okay, then substitute just this one. This will be minus 1 by 2 ln of this expression here, v plus 5 by 6 square, okay, minus 49 all upon 36, yeah, equal plus 3 by 7, then ln of v minus 1 by 3 and v plus 2 equal to dx, this one is ln of x plus c. You see, now substitute for v, what is v? V is equal to y upon x. Okay, v is equal to y upon x. Do you remember where we come from? Okay, I guess you can remember this one. Okay, and so in this way you can solve this exercise. Okay, yeah, v is equal to y by x. So just substitute in there. Let us substitute. What we are going to find, it will be v is equal to y by x, so it will be minus 1 by 2 ln of y, okay, greater y, it's like y upon x, okay, minus plus 5 by 6 square minus 49 upon 36, then plus 3 by 7 ln of y upon x, okay, minus 1 by 3, and here greater y upon x plus 2 equal to, this is small x plus c. Now, do you remember that we said that this greater y is equal to will be equal to y minus, it's like we made a substitution like this. We said that greater x is like capital X is equal to capital X plus h is equal to h, and capital Y, okay, plus k is equal to y, small y. So it's time to be back from this one. Yeah, now the point is how to find h and x, because we have to change here the capital Y must be changed by small y. Okay, so we have to find what is k and what is h. Nice. Now see, to find this, we remember this one. Okay, do you remember this equation? Okay, because we made them equal to 0. So 2h minus 3k plus 2 must be equal to 0, and 2h plus 3k, okay, minus 1 must be equal to 0. Solve it in many ways. You can solve this one by reduction. Just reduce this one and this one. Sum all of this one. This will be 1, this will be 0, and this will be 4h. Okay, plus 1 equal to 0. So h will be equal to 1 negative by 4. So if h is 1 by 4, just substitute in here 1 by 4 and find what is k. Okay, so this will be 2. Okay, 2h. What is h? Minus 1 by 4. Okay, minus 3k plus 2 equal to 0. I'm substituting in the first equation. Just find this one. This will be minus 1 by 2 minus 3k plus 2 equal to 0. Now, this one and this one, okay, what will it be? It will be minus 3k, and here it will be plus 3 upon 2. Just find the common denominator, equal to 0. So it means that k will be equal to 1 by 2. Okay, k is equal to 1 by 2. Now that k is equal to 1 by 2 and h is equal to minus 1 by 4, now you can substitute in here. Okay, yeah. So the general solution will be directly from there. This will be minus 1 by 2. Okay, directly from there, as you can see there, minus 1 by 2, where you find greater y or capital Y will be substituted by what? You know this? Okay. Greater y plus h is equal to x, and greater x plus h is equal to x, and greater y plus k is equal to y. Just substitute this one. So what we mean? X, okay, like what we mean is that where we find greater x, we will substitute by h minus x minus h, and greater y, it is y minus k. Okay, what is this? This will be h minus, what is h? Minus and minus, plus 1 by 4. And what is this? Y minus, and here it is 1 by 2. K is 1 by 2. So we'll substitute this. So this will be y. This, what is y? Y is y minus 1 by 2 all upon x. X is x plus 1 by 4. Okay, yeah, this one plus 5 by 6 all square minus 49 upon 36. You see? Yeah, then just substitute plus 3 by 7, then ln of, just find out for this equation. So in this equation, as you can see, you can just simplify also. Simplifying this, here you'll get x down, and here you'll get x. It will be y minus, this will be 3y minus x, and here it will be what? 2x only. Okay, y plus 2x, and x will be cancelled out. So here we will get only 3y. We know that y is equal to, this is capital Y is equal to y minus 1 by 2. Okay, minus x. What is x? X plus 1 by 4. Okay, all upon, and here it will be y. What is y? Y minus 1 by 2, and x, okay, plus 2x. What is x? We know that x, it will be x plus 1 by 4. Okay, yeah, and this is equal to all this expression is equal to ln of x plus c. Amen. From here, I have no way to solve or to try to simplify anything. Okay, I will not simplify anything here. Here it's okay. From here it's nice. Okay, it's nice, and it is solved. Okay, yeah, this is 1 by 4. Okay, hope you may understand the main concept here. Okay, the main concept. The rest is just integration. And for this exercise, for the other one, suppose we have the second exercise is, let me see, where is this? Okay, the second exercise is this one. Okay, for this one, suppose we have dy upon dx, okay, is equal to 3x minus 4y plus 3 upon 12x minus 16y and plus 1. So here what we have to do, you have to find this and this. Okay, the same, we have to check whether this upon this is equal to this upon this. So m1 is equal to 3 by minus 4, and m2, okay, we know this is m2. Just compare this with this expression a1x plus b1y plus c, and a2x plus b2y plus c. Okay, just compare, then make this and this and this and this, and here you'll get m. So this will be what? 12 by this one. This will be 12 minus 16. So this one, you know that here you can divide by 4. This will be 3 by minus 4 also. So it means that here m1 is equal to m2, meaning that 3 minus 3, 4 is equal to minus 3, 4. So here the substitution is the opposite, okay? Here the substitution is making only x, okay? Making this expression, okay? Or this expression equalizer. So here you'll do this one, dy upon dx equal to this expression up, okay? This expression, here this will be 3x minus 4y plus 3 all upon, here just take common 4. 4, this will be 3x minus 4y2 plus 1. Now see, here what you do, you can do this substitution. We will make this, okay, like 3x minus 4y equal to v or u, it's upon u, okay? This is equal to this. Now find the differentiation. So dv upon dx will be equal to d of 3x minus 4y with respect to x. So dv upon dx will be equal to this and this. This will be 3 minus 4 dy upon dx. Is that okay? Yes. If this is okay, so what you have to do, find what is dy upon dx with respect to this guy. Send this one there. This will be dv dx minus 3, okay, equal to minus 4 dy dx. Then multiply by minus 4 here, multiply by 1, okay, minus 1 by 4. And here also minus 1 by 4. What you are going to have? You're going to have something like this. This will be minus 1 minus dv upon dx, okay, dx all by 4, okay, just like this. This will be minus 1 by 4, okay, sorry, it's okay. So this will be only this, okay, this will be dv upon dx, okay, minus 1 here by 4, okay, minus 1 by 4, minus 1 by 4 dv dx, and plus 3 by 4 is equal to dy dx. Okay, just pick up the most important expression, okay, call this star and this double star. Is that okay? Now what you have to do, just substitute, okay, where you find v, suppose this here, where you find v, where you find like 3x minus 4, put v, and then you can just solve this one directly. It's okay? Yeah. Let us see now. dy dx, what is dy dx? dy dx is minus 1 by 4 dv dx and plus 3 by 4. This is dy dx. Then I have there 3x minus 4x is equal to 4y is equal to v. So put there v. This is v plus 3 all upon 4v plus 1. Okay? Is that okay? No, it's okay. So what you have to do now, just to put together all the terms that have v with dv and all the terms that have x with dx. So what you have to do, dv, okay, dv like this, okay, if it is like this, dv, it is equal to what? Minus 1 by 4 and dv dx plus 3 by 4. Yeah, just solve this one, just solve. This will be minus 4, and here this guy, okay, minus 4 dx, then this guy can go there. It will be v plus 3, and here 4v plus 1. Okay, then minus 3 by 4. Find the common denominator. What you are going to have? Yeah, the v 4 dx, common denominator here, 4 come here, this will be 4v plus 12 minus this and this will be minus 12v, and this and this minus 3, all upon 4 times 4v plus 1. Is that okay? Yeah, it's okay. Now what's the next step here? Just find the common there. This will be minus 8v and there plus 9, all upon like 16, 4v plus 1. And here you have minus dv upon 4 dx. This 4 and this 4 can be cancelled out. These 2 4 can be cancelled out. This will be only this expression. So this will be minus, this come here, 4v plus 1 dv upon this come down. Okay, upon minus 8v plus 9. This is dx. Okay, now this expression is very easy to solve. Okay, you can just solve this directly. Here you can do. See, here you have 8 and here you have 4. Yeah, you can just play this one a bit. Okay, you can just play how to solve this integration. Now you have to apply integration and integration. Here it is minus can go down and just multiply by here. This will be 4v plus 1 all upon this down will be what? This equation here. This will be 8v minus 9. This integration. dv dx integration. Now see, dv dx, what do we have to do? Okay, this integration is very easy to solve. Okay, you can just solve it directly. You can just do what? Okay, you can just find the division between them. Just divide them. Okay, divide them directly, like doing this one. See, suppose here you have this one and this one. This is 4v plus 1, and here just dividing by 8. Dividing by 8 here and 8 here, it's upon you, all 4 and 4. So yeah, here you have 8v minus 9. But see, here you can come only and divide both sides, okay? Here you can divide by 4, and here divide by 8. What you are going to say? You are going to say this, okay? If you divide it by 4 and it is divided by 8, this will be v plus 1 by 4, and here, okay, this 4, and this is the 4 here, and here do the same, 8 and v minus 9, okay, 9 by 8, dv integration of dx plus c. See, okay, this and this will be only 2, okay, sorry, this will be 1 by 2 integration of this guy, v plus, okay, yeah, v plus, see, if I want just to simplify this, I can come here and say v minus 9 by 8, okay, apart, and plus 9 by 8 plus 1 by 4, okay, then it will be also v minus 9 by 8. Now see, dv equal to integration of dx plus c. Now see, if you do this, what is happening? I just add and take, okay? Add and take normally. This is the same as this. What's the next step? Now separate this integration. Just sum this, okay? Find the common denominator here. It will be, and here this will be 2 plus 9, 11 by 8. This is nice, it's nice, okay? It will be 1 by 2. This integration and this one divided, this and this will be 1. It will be all integration of dv, okay? Then the next integration is plus, okay, 1 by 8. This integration, if you just sum, Sum this one, okay, find the common denominator, it will be 11, okay, this will be 11 by 8, okay, dv upon v minus 9 by 8, okay, equal to integration dx plus c. Now this one can go here, this will be 1 by 2 integration dv plus this will be 11 by 16 and integration dv, okay, this v minus 9 by 8, you can write this, and here it is v minus 9 by 8. Is that okay? Equal to integration dx plus c. Now that you know, you can just do this is 1 by 2 times v plus 11 by 16, and this integration is ln, okay, ln of v minus 9 by 8 equal to x plus c. Is that okay? Now you have just to go back. We said that v is equal to 3x, okay, minus 4y, okay, then substitute this one. This will be 1 by 2 3x minus 4y, okay, plus 11 by 16 ln of 3x minus 4y minus 9 by 8, okay, is equal to x plus c. So this is the solution of this exercise. Okay, I hope you may understand. Okay, you may understand something. The most important thing that you have to grab in here is that whenever you have an equation like this, okay, like this, just check for the rate of change of this one. Check if this by this is equal, okay, to the if this 2 by 3, okay, 2 by minus 3 is equal as 2 by 3. If they are equal, so you have to apply this this change here, okay, just apply the substitution and you go and find them. But if they are different, apply the substitution, you have a long way to go. Okay, thank you very much. I hope you may enjoy and understand this thing.